Okay, so yeah, sorry I missed that last little bit. So what we'll do, I'll put that last lesson up as well so we can have a look. Paul, you got a question. So do you want to ask it in chat or do you want to put it in the one? Okay, go for it. Yeah. Oh, did I? Express the following angles in radian measure. No. So with that 1.9, 1.9. Express the following angles. Oh, in radian measure. Oh, that's because that's a typo. It's already in radian measure, so that would be the easiest question in the world. That'd just be copying it again. So that should be. So here it should say degrees. So 118. So so I may as well finish this question now because we've got a little bit of time. So with that 472, let's go hook the pen up again. So if they ask me to do 472 degrees into radians, the normal process is just 472 on 180 times pi, which we're just going to leave as the fraction, right? Because that's nicer. But you can simplify that fraction. 472 on 180, that's the same as 118 on 45. So that is the correct answer. Here. Ugh, terrible highlighting choice. All right, that's the correct answer because it's simplified. Oh, because, so I would be careful, Alfie. Pi and 180 isn't pi, right? That's how you convert between the two. So it's a bit like meters and inches, right? So you can convert between the two. So if you want to go to radians, then pi will represent in radians 180 degrees. Right? So it's two different ways of measuring the same thing. Don't worry about that. All good? Minus 2 pi. So this is the good bit that I'll go through again. So for those of us who were in my class last year, 472 degrees, if I ask you to find the sine, cos, or tan of that, the first thing I would get you to do is to subtract 360 from that. 472 degrees is ridiculous. Why would you want that? So we're going to go backwards 360 degrees. So we take away 360 degrees. So 472 degrees minus 360 degrees gives us the 112. That means that this angle and this angle are exactly the same thing, right? They put you in the same quadrant, right? Which is what I demonstrated here. Okay, that angle of rotation there is 472 degrees. Okay, starts at 0, goes all the way around. Oops. What's going on? Okay, cool. So it starts at 0 degrees and goes all the way around, and then 112. So 112. These two things are the same. So we can. Does that make sense? So we get this line here. If we did that in radian measure, however, we can't subtract 360 degrees because that's in degrees. What we have to do is do a subtraction of 2 pi. So if we have 118 pi on 45, I can take away 2 pi. So these are equivalent. Remember, these are the same. Now these are the same. And so what I'll end up with is another angle that is exactly the same. And in this case, that ends up being, what's that, 90, my brain's gone to sleep, 1028. So you end up with 28 pi over 45. Okay, so now let me go to Alfie's one first. So why is so this is a unit change, just like there are a certain amount of inches in a centimeter, right? That's the way we convert between the two. This 180 bit. Kieran, sorry, I'll go back to yours in a second, Tom. Kieran, not really. We just like angles that are between 0 and 360. That just makes sense because we want to stick in that same rotation. But to be fair, if this question asked me to convert 472 degrees to radians, then I would give this answer, 118 on 45. There's nothing wrong with that answer. I'm just saying we've got to be able to, all the things we could do with angles before, we can do again, but we can do it in radians now. So if we can add and subtract 360 to get equivalent angles before, then now we can add and subtract 2 pi to get equivalent angles, because 2 pi in radians is 360 degrees. Does that make sense, Tom? Oh, that's just fractions. So if you ignore the pi here, right, so this is the easiest way to do these things. These are both fractions of pi. So what you can do is just ignore it. So really, if you did 118 on 45 minus 2, right, you'd have to get equivalent, you'd have to get a common denominator. So you get 118 on 45 minus 90 on 45, which is 28 on 45. Right, so that's just fractions. So that's the beauty of leaving it in fractional form. We can just deal with it like fractions. So we need to add and subtract angles. We're really just adding and subtracting fractions and then chucking a pi on the end of it. Cool. All right, so we've got a couple of minutes. Are there any other questions? And we subtract 360 because it is over 360 questions. Exactly right, Alfie. And that's the radian measure. That's exactly right. So this is the radian. Anything with the pi in it then is going to be the radians, right? And we can do all of operations in degrees, but radians is a significantly better measure, and in fact, that'll be the measure we use from now on. So we're going to get used to radians. Alfie, as I said before, you can use the little symbol, the little tiny c, superscript c, but if we're dealing with trigonometry, your answer is assumed to be in radians, so you don't have to. You can leave it like I have. Yeah, that's right. Paul, that's perfect. If you're concerned, if you did 28 over here, if you then took this answer and converted it back into degrees, so you do 28 times 180 on 45 degrees, you would end up with 100 and, what do we say? 112. Which it should be. All right, so like I said, I'm going to upload these videos so you can have a look at it a bit later. If they're a bit long, I'm going to have to put them on YouTube, and then I'll put the link in. Otherwise, I'll just put them up on Canvas, and I'll put it on our class page, so you can have a look at those ones there. Any questions? Yeah, we're going to do the work tomorrow. Don't worry, Alfie. You're all right, mate. Don't freak out. So, Harry, there's a little bit more work we've got to do before we do those, which I want to go through, and then we can do that, which would be good because tomorrow I want to practice. Yeah, so you need the trig as well, like this. Okay, it's not a big deal, but I want to do that, and then during the lesson, we can work on those, and then we can test how good Zoom is at me helping you with your work. All right, it's 11:45. I think you've got another period now, so enjoy. I'll let you know where these are tomorrow. Until then, see you later. Enjoy. Oh, hang on. I'll say goodbye quickly. Enjoy remote learning. Bye.